Hi, this is Royce, and I'm going to cover a soil test analysis. So right now we're looking at the soil from Space Ghost, who sent us some soil in, and we had the analysis performed, and I've performed some calculations on that analysis. So the nutrients that were measured in this soil sample are phosphorus, potassium, calcium, magnesium, and we also have a hydrogen measure, which just measures acidity. Some other data that we have our pH level, 7.5, and our cation exchange capacity, which is 31.4. So let's talk about some of the important features here. I noticed that the soil sample, just with a visual look at that soil, it looked like organic material. And so that means that this cation exchange capacity is very high. It's 31.4. So what is that? Well, that's the soil's ability to retain nutrients. And so anything above, I would say, a CEC, a cation exchange capacity, of 5 or greater is going to be a pretty good soil, especially if you have 12 or greater. This soil is 31.4, so it's very, very good soil. Besides that, we have our pH level of 7.5. Our ideal would be something close to 6.4 pH. It's telling me that the pH is a little bit high, and that's also telling me that the nutrients are a little bit out of balance. If we look at our individual nutrients here, I want to look just really quickly at the most important nutrient here, which is calcium. And so in our soil sample results, we have a parts per million level of 3,840 parts per million. And so when we look at that parts per million in relation to all the other minerals here, it's going to be a 61.15% saturation of calcium. So that means that 61% of the nutrients in the soil are calcium. Our ideal ratio, which is this table here, for calcium is around 68. So we're pretty close on this one. We'd like to increase it just a little bit, but it is worth noting that still calcium is the predominant mineral in here. If we look at magnesium, that's at 1440 ppm, and it's taking up 38% of the mineral content of the soil. Now that is pretty high, because we would like it to be 12% or around 12%. And so that's leading me to believe that this high pH level, 7.5, is more or less caused by a high magnesium level. And also, we have to compare that to our hydrogen level. Now, in soils, the hydrogen content is really just like an empty space. It's hydrogen in the soil that could be replaced by nutrients that the plant actually uses, such as magnesium, calcium, or potassium. So right now we have a 0% saturation and a 0 ppm level of hydrogen. So what we're saying here is that this soil is really saturated with nutrients. The one that I'm concerned with here, really, is the potassium level. We only have 78 ppm in potassium. And so it's less than 1% of the nutrients in our soil. If we look at the ideal ratio, it should be 8%. And we should have 979 ppm rather than 78. So when I make my recommendation, I'd really like to add some sulfur. That's what I'm going to talk about down here. And I'd also like to remove some of that magnesium. So I'm going to take care of that here also. The difference table, it just tells us in parts per million what the difference is. So the one nutrient that I didn't really look at yet is the potassium level. Now the reason why I kind of put it to the side is because potassium, unlike the rest of these, it has a negative charge. It's really easy to get bound up in the soil, and it doesn't stick to the soil like the other nutrients do. We don't necessarily have a correct ratio for it, but we do have a recommendation, and that's 100 ppm. I forgot to mention, what the heck is ppm? It's parts per million. If you have 1 million pounds of soil, and if you have 1 ppm of a nutrient, that means you have 1 pound per million pounds. To put it in perspective, 1 acre of soil, 6 inches deep, is about 2 million pounds. Whenever we have 1 ppm of something on 1 acre, that means it's about 2 pounds per acre. Consider this ppm level to be, suppose if you had a ½ acre of land, you would have 157 pounds on that ½ acre. So right now we are within range. We are actually above the minimum recommended, and so that's good. I would consider this to be a high phosphorus level, so I'm not going to make any phosphorus recommendations. We do want to add about 900 ppm of potassium to the soil. We want to add about 430 ppm of calcium to the soil eventually. I don't want to touch the calcium just yet because it's looking okay. And if we flush a few of the other nutrients out that should not be there, then I think the ratios are going to come back into balance a little bit better. And right here, this magnesium, we would like to remove just about 1,000 ppm. Is look at our recommendations here. And this is really going to tell us what we need to do with the different quantities. We have pounds per acre, and it's telling us exactly what we should do with our soil. So the potassium content, for instance here, we should add 1,800 pounds per acre potassium. And then calcium, it says add 861 pounds per acre and so forth. And it says remove this much magnesium, 1976. This data is given in different forms. So here's the pounds per acre. I also calculated it in pounds per square foot. So these two columns of data are basically equivalent. This is for organic media. It's taking into account how light organic matter-based substrates are. So things like peat moss, coconut coir, pine bark mixes, they're a lot lighter than mineral soil. And on like a per cubic foot basis, mineral soil is about 90 pounds per cubic foot. Like I said, 2 million pounds per acre. That's what mineral soil is, if you take it about 6 inches deep. Organic matter per cubic foot, if you take all the water out of it, it's only about 4.5 pounds per cubic foot. I've converted all these into milligrams per cubic foot of organic media. Now this is what I'm using to actually make my recommendations down here. I'm saying let's add some potassium in the form of potassium sulfate. And so potassium sulfate, you can find it in powdered form. It's a fine pink colored powder. It's pretty heavy, and I like to use it in soils that don't have a lot of potassium, or they need to get some sulfur added, because the second half of this is potassium sulfate. Once we build up sulfur in the soil, it's going to be available to bind to other nutrients in the soil. So what I'm hoping for is for some of this sulfate to grab a hold of some of this magnesium, this 1440 ppm of magnesium, and it's going to grab onto it in sulfate form. So hopefully magnesium sulfate, and we're going to let it flush out either with rain or if we water the garden and it runs out naturally. And if you're working with acres, we would do 4,000 pounds per acre of potassium sulfate. I wouldn't apply it all at once. I would do it maybe in the spring and in the fall, maybe for a few years. You could break it up into maybe 4 applications, and you could build it up slowly over time. We also have a calculation for pounds per 100 square feet. And so if you're working with an acre, you would use this one. This is really just like a 10 by 10 garden, just in your backyard. You would use 9 pounds of potassium sulfate, which is not that much. I can hold it in my hand, basically. It's maybe like a gallon-sized freezer bag. You would maybe have that halfway filled, and that would be 10 pounds of potassium sulfate. It isn't very much. Grams per cubic foot, that's mineral soil. If you're working with maybe a container, a cubic foot is about 7.5 gallons, just to give you perspective. But it's just 1 foot by 1 foot by 1 foot, and we would need 42 grams of potassium sulfate there. So just for convenience, we have different measures of it. And if we're using organic media and we have like a large, maybe a 7.5 gallon container, we would add 2,084 milligrams. Maybe that's better stated in grams, just over 2 grams. How should you apply this? Well, you could shake it onto the soil surface and it'll become water soluble all by itself. or you can mix it up in your irrigation water and you could apply it that way too. The elemental sulfur that I'm going to recommend here, we're looking to create that sulfate in our solution. And elemental sulfur, oops, I actually made a little error here. It's not 45% potassium, it's actually 99% sulfur. And hopefully that's gonna help take out some of that magnesium. We're gonna get 538 pounds per acre. And again, you shouldn't apply that all at once. If you're going to apply it, I would do this in 2 applications. Pounds per 100 square foot, if you're working with a 10 by 10 just garden, 10 foot by 10 foot in the backyard, I would use 1.25 pounds, which is really not very much at all. I can fit it in the palm of my hand. It's just a fine yellow powder. That's the way I get it. And it's very water soluble. You could sprinkle it on the soil surface, or you can mix it up in some water and irrigate the top few inches of soil. If you have a sulfur molecule and you have 4 water molecules, what happens here is that these are going to combine and form SO4, which is sulfate. And so whenever we take those 4 oxygens away, we're actually left with some hydrogens. That's how we are going to acidify our soil. And that is going to help get our pH number down. And you see here, when we have our H plus figure here, right now we have 0 ppm and our nutrient level is at 0%. We'd like it to get more towards 10% or 31.4 ppm, right? All those hydrogens are going to help do it. Once they strip out some of the extra magnesium from our soil, then we hope that there's going to be some empty space there, and it gets us down to hopefully 6.4 pH is ideal. And in that range, all the different nutrients that a plant uses become mostly available in the correct ratios. That's what we're going to get to as we add this elemental sulfur. I wouldn't do any calcium additions right now, but if you wanted to, you should use calcium sulfate. We would not want to use calcium carbonate, which is just ag lime, because that carbonate is going to tend to raise our pH. Stick with the gypsum if we're going to add any calcium source. But these are the 2 elements that I would like to add first. Well, the 2 chemicals, potassium sulfate and elemental sulfur. And I do believe both of them, you can get them OMRI for organic production. I don't consider potassium sulfate to be too harsh of a chemical. Again, a lot of people use gypsum in their soil, which is really just calcium sulfate. And so this is just the potassium form of that sulfate. Elemental sulfur also not too harsh. And the soil microbes, when the temp of the soil is above 50 degrees, they're going to help to convert that sulfur over to sulfate. And they're going to get that sulfuric acid produced in the soil. Those are my recommendations for now. And I would say that after you make your first application of these amendments, that you go ahead and test the soil again and see what kind of balance you have afterwards. And since this is a organic soil, I would say that maybe you should do a soluble salt analysis on it. And also if you get a saturated paste test, which is where they take the soil sample and they put reverse osmosis or deionized water in that sample, and then they just let it sit there for a while, take that water and then test what has leached into the water. Because with organic matter-based soils, it's really important to know what's happening in the soil water, because that's really what the plant sees. And that's really because that media does hold so much water. And it doesn't have the same physical properties that mineral soil does, like with clay, silt, and sand. The minerals are available in slightly different ways. My recommendation is, if you really wanted to go further with this, you would check out the soluble salts, which usually comes on the saturated paste test by standard, and then check out that saturated paste. And there are recommendations for the levels you should see there. This test is a Malic 3 analysis. It's using a strong acid to strip out the minerals from a small soil sample, and then those measurements are made on that solution. That's what we are looking at here, and that gives us a really good ballpark of what's actually in our soil. This is Royce, and we are analyzing the soil from Space Ghost. And to the best of my knowledge, this is how I would treat the soil if it was me. And then after I make the amendment choices and then apply them to the soil, I would wait a few months and then retest and then see if my levels came back into balance.
Want to know what's in your soil? Go to aggergrand.com, get a soil test where we'll tell you your soil's nutrient deficiencies so you can grow healthy plants that you can eat.